Welcome to Study Loop.
So here in this problem, we are given that there is a homogeneous crate of mass m, and we have to determine the maximum force which can be applied that the crate doesn't turn. And we are given that the force is applied at a distance of h equals to b from the lower end. This is the part A. We will be solving the part A first. So we'll be considering a limiting case where the crate is about to tilt about point A, and we have drawn the free body diagram also, as you can see in this figure. Now when the body is about to tilt about point A, so the normal reaction at point B would be 0. Now we'll be applying the second law of Newton on the body, so we can write that sigma F net is equals to mass into acceleration. Now the forces acting in the x direction, we have only the force P, so P would be equals to mass into acceleration. Now if we calculate the expression for acceleration, we'll get A is equals to P over m. Now next we'll be applying the equation of motion in terms of moment at point A. So we can write that sigma moment, sigma m, is equals to I into alpha plus MAD, where alpha is the angular acceleration about the mass center and I is the moment of inertia about the mass center, and D is the perpendicular distance about between the point of a rotation and the MA component. So this distance would be D. So we can take moment there. The moment about there would be two forces acting. Sorry, three forces. That is the force P, mg force, and Na. So we'll be taking moment in the clockwise direction to be positive. So P times B, we are taking moment about point A, minus mg times c over 2 plus Na. The moment due to this force would be 0 because it is passing through this point. So this would be 0. And it would be equals to I into alpha, so I as it is. Now there is no angular acceleration here, so this term would be 0 plus mass as it is times acceleration we have calculated as P over m, so P over m times B by 2, because the distance D is this much distance and this distance is B over 2. Now from here we're going to simplify for P, and we'll get PB minus mg c over 2 is equals to Pb divided by 2. So from here we'll get the expression for P as mg times c over B. So this is the maximum force which can be applied on the body, and the body will not rotate. So this was the answer for the A part. Now next we'll be solving the B part. Now we'll be solving the part B. Now in this case again we have to calculate the force P, the maximum force P which can be applied on the crate so that it doesn't turn. But in this case the force P is acting at the lower end, as you can see in this free body diagram. So we'll be following the same procedure that we did in the part A, and we'll be applying the equation of motion in the horizontal direction first. So sigma F net is equals to mass into acceleration. So the force in the horizontal direction, we have the force P only, so P is equals to m times A. So from here the expression for acceleration is same that we obtained earlier, P over m. Now next we'll be applying the equation of motion in terms of moment, but this time we'll be taking about the mass center. So sigma m is equals to I into alpha plus m times A times t. Now in this case also there is no angular acceleration is there, so this alpha would be 0, that means this whole term would be 0. Now the distance d, because we are taking the moment about the mass center, so there would be no value of d, that means the value of d should be 0 in this case, so this whole term would be 0. Now simply we can take the moment about the mass center and equates to 0. So P times B over 2, and we are taking moment in clockwise direction to be positive, plus mg times the perpendicular distance is 0 because we are taking about this point only, minus nb times c over 2, and it is equals to 0. Now here we don't know the value of nb. For that we'll be applying the first law in the y direction, or we can say that sigma fy should be equals to 0. There is only two forces acting, there is, yeah, nb is acting and ng is acting, so nb would be equals to mg. We can plug it here. So P times B over 2 minus, or we can take this thing towards the right side, so equals to NB, we have mg times C over 2. So this 2 and 2 will cancel out. So again from here we'll get the expression for P as mg times C over B. So this is the answer for the B part. This is the maximum force which can be applied on the crate such that the crate will not rotate. So I hope you have understood the problem. Thank you.